Like other commuters in the South Bay, the people who work at Ames Research Center have to navigate the same boring traffic as everyone else. But between the hangar that once housed a 1930s airship and the largest wind tunnel is a world that takes them to the boundaries of human exploration.
2, 1, and liftoff.
In the 1960s, the concept of a space shuttle was pure science fiction, until NASA and President Nixon announced the Space Transportation System in early 1972. This space vehicle would launch like a rocket to low Earth orbit. Its crew would release satellites and deliver parts for the space station. A fiery plunge back into the atmosphere would turn the vehicle into a glider that could be piloted to a controlled landing on a runway. It would be the most complex machine ever built. On April 12, 1981, NASA successfully launched STS-1, the first shuttle mission. Safely accelerating this machine to 17,500 miles an hour required years of sophisticated aerodynamic tests. Over half of all wind tunnel tests for the shuttle were done at Ames. These facilities provided an unmatched range of sizes and speeds. In the 1970s, Ames tunnels allowed scientists to actually see complex shock waves created by the shuttle before the first orbiter, Columbia, ever flew. The same wind tunnels conducted safety tests of new fuel tank features in 2005, before the shuttle returned to flight status. Ames computer simulations began in the 1970s and then improved exponentially. Today they can simulate speeds and conditions no wind tunnel could match. Work done on the Columbia supercomputer helped put the shuttle back into flight in 2005. The shuttle has performed many transportation tasks while in orbit. Dozens of satellites and spacecraft were launched from the payload bay. One was Galileo, which was developed in part by Ames and eventually spent years orbiting Jupiter. It sent back breathtaking photos. More recently, shuttles have carried components of the International Space Station. All astronauts agree the perspective from orbit is breathtaking, but not all of them are comfortable with zero gravity. Now that humans are spending more time in this environment, the study of how it affects living organisms is critical for the future of spaceflight. Ames Life Sciences Division explored this subject for over 40 years. Some experiments were done on the ground and others were conducted on the shuttle. Flight experiments were installed in specially designed lab modules carried in the shuttle's payload bay. Starting in April of 1991, Ames participated in shuttle missions such as Space Lab Life Sciences 1 and 2, International Microgravity Labs 1 and 2, Space Lab J, and NeuroLab. These studied the effects of spaceflight conditions on plants, animals, and humans. Now we have a much better understanding of how zero gravity affects our balance and visual perception, how muscles, bone, and blood are affected, how immune systems change, and how plants grow. Results have already helped astronauts adapt to different gravity levels on missions and recover faster after landing. Next to launch, re-entry is the most dangerous part of a shuttle's flight. Ames developed a technique in 1953 that has been used by all American spacecraft since then. Ames scientist Harvey Allen rendered 1950s spaceplane designs obsolete. He showed that a blunt body, not a pointed one, could survive re-entry better by creating a shock wave that would act as another heat shield. This idea was used to create the shapes for Mercury, Gemini, Apollo, and every other American space vehicle. Although the shuttle uses the same principle, it still needs insulation from extreme heat. Starting in the 1970s, Ames scientists developed feather-like insulation tiles. Ames also developed the largest arc-jet wind tunnel. This high-speed blowtorch allowed them to test tile material at 3,500 degrees, the same temperature as the outer surface of a shuttle during re-entry. These reusable tiles were so successful, they were incorporated into most of the shuttle's main heat shield surfaces. After a shuttle lands, the stress on the tiles is obvious. To help the technicians check thousands of tiles for damage, Ames developed a handheld laser scanner that speeds the process considerably. After debris damaged the leading edge of Columbia's wing in 2003, the ArcJet was tasked with testing proposed patch materials. The resulting test data was fed into the Columbia supercomputer, which further predicted reliability on re-entry.
Go for landing, over. Roger, understand. Go for landing. Flight. Okay, we're going.
A shuttle during descent has been described like a brick with wings. An early question was how to give it effective flight control. Ames' earlier innovations provided a foundation for the shuttle's basic concept. Starting in 1957, Al Eggers and Cy Syvertson developed and tested lifting bodies, simple shapes that could survive re-entry and provide just enough lift and control so they could glide unpowered to a safe landing. High-altitude drop tests at Edwards Air Force Base in the 1960s proved their airworthiness. Before the Orbiter Enterprise was flight tested in 1977, Ames did extensive wind tunnel tests of the shuttle perched atop its 747 carrier aircraft. Starting in 1970, long before a final shuttle design, a flight simulator at Ames allowed astronauts to fly approaches while testing prototype flight controls. Astronauts Gordon Fullerton and Fred Hayes practiced in a larger and movable simulator at Ames before climbing into the Enterprise. Minor control problems on the first flight were ironed out in the same simulator to improve later tests in 1977. The commuters who come the farthest to Ames are the shuttle pilots and commanders. Starting with the crew of the first mission, STS-1, every shuttle pilot and commander has practiced hundreds of landings in Ames Vertical Motion Simulator. It offers the most realistic motion available. The head-up display developed here was incorporated into Columbia's cockpit before the first flight in 1981 and is a part of every orbiter today.
You're looking great.
Ames wind tunnel tests also proved the safety of the long-distance carrier that returned the shuttle to Florida after landings in California. Today, NASA is developing the Crew Exploration Vehicle. This Apollo-shaped capsule will take astronauts back and forth to the moon. Like it has for over 40 years, Ames is contributing the same level of scientific expertise and craftsmanship to help create this new space vehicle. And like they always have, Ames staff is still working with one foot on the ground and another at the edge of human exploration.